Hello, my name is David Workman. I've recently created two Sudoku puzzles as kind of the pair that go together in a theme. It's my very first time actually creating a Sudoku puzzle. I've been solving them for many, many years, but had never really thought about what the process was to create a puzzle. So I finally got motivated to give it a try, and I just wanted to go through the process that I went through of how I created the puzzles and what my goals were. There's a YouTube channel called Cracking the Cryptic, which is very popular lately, which two guys in the UK, Simon and Mark, who are very, very good at solving these really high-end, very difficult, competitive championship level puzzles. And after watching this channel for the last couple of months, it kind of motivated me to give it a try myself. Now, one of the things that they do, as you can see, like this one up here, is they do a lot of chess variation Sudoku puzzles, which means that they use chess piece moves as restrictions for what you can do with the Sudoku puzzle. Now, typically these are just what they call king's moves restrictions or knight moves restrictions, meaning that if you have a king on a board, you cannot have another king that's in a king's move away. So like even if there's a king here in this box, you can't have one here on the diagonal because they'd be in check with each other. The knight's move restrictions are if you have a knight here, you can't have another of the same piece here or here or here or here because it's a knight move away. But all of these previous games that they usually play, it's one piece against itself. So if the number 3, you can't have another number 3 in a knight's move configuration. And I wanted to mix that up and do something a little bit different. So what I've done is I've assigned the kings as number 1, bishops as number 2, and I've never seen a game with bishops before, so this is kind of a unique thing that I've invented here. And then a knights is number 3. So the rules of the game, and again I have 2 different games, but the first one is normal Sudoku rules apply. Kings are 1, bishops are 2, knights are 3. Now no 2 kings can be a king's move apart. No king can be a knight's move from a knight. And then here's kind of the wrinkle. No king can be on the same diagonal as a bishop unless a knight is blocking the path. So that's kind of more realistic to how a real chess game would work, whereas the king would be in check if there was a bishop here, unless there was a knight or some other piece blocking the path. So that's kind of the rules for puzzle number 1. Now, puzzle number 1 just happens to be in a stalemate situation. You don't really need to know that in order to solve the puzzle, but it's part of the story for the second puzzle. So in box 5, in the center box of the grid, wherever the king is in that box, it's not in check, but all of the cells surrounding that king are in check, so that the king could not move to any of its surrounding cells. Now, when we move to, so it's in a stalemate situation. Now, when we move to puzzle 2, the checkmate, this is the same rule set, except for the king in box 5 is in a checkmate situation, meaning that it is in check by one and only one bishop or a knight. Now, this is interesting because, one, it means that one bishop or a knight breaks the rule here of no king can be a king's knight away or one bishop can be a bishop's knight away. So there is one piece that does break that rule. The second thing is that as you fill in the middle box, you can't eliminate possibilities because you don't know if that knight or that bishop might be the one that's putting that king in check. So it actually makes the puzzle quite a bit more difficult, both from the authoring side when I was creating the puzzle and then from the solution side to solve it. So going back a little bit, I wanted to go through, again, this is my very first time ever creating a Sudoku puzzle. And, I learned a lot. There's probably many more efficient ways of doing it, but I wanted to kind of go back and show, there was a program that I wrote about 15 years ago. Actually, it was 2006 that I wrote it. So 14 years ago, where I just wanted to brush up on my programming skills. I'm a relatively good mathematician and algorithm person. I can implement just about any mathematical function in Visual Basic, no problem. But I'm not a very good general purpose programmer, just on general terms. So I just wanted to brush up on my skills, and I was also very interested in doing a recursive algorithm to solve a Sudoku puzzle recursively. And because every time I had tried previously to do a recursive type programming routine, I failed miserably at it. So I actually did it. It worked fine. Everything was great. And let me go ahead and run that. Actually, I've now forked the code because I've now made a version of the software that takes into account these king's move conflicts and the knight move conflicts and the bishop move conflicts. So I've kind of modified the code. But first, I'm going to go back to the original program that I wrote 15 years ago. And let me clear these boxes, and let me just put in some funky numbers: 1, 2, 3, 7, 8, 9, and 2, just as an example. Now, this brute force algorithm is what I use for the recursive algorithm, and it kind of goes through, and it just that actually finished pretty quickly. It finds the very first solution that creates a valid puzzle. So it basically just recursively goes through, plops the numbers in, until it finds a set of numbers that don't violate the Sudoku rules, meaning there's one number in every row, column, and box. But it doesn't mean that that is actually a unique solution based on those numbers that I put in. It's just the first one that it found. It turns out that is actually very useful for when I was going through to create these new puzzles. So let me go back now to my current software. So this recursive routine, I do two nested loops: row count, rows 1 to 9, columns 1 to 9, and then I go through the numbers. I have this conflict flag, which I go through and I check the array for conflict. So that's basically making sure that you don't have two number 4s on the same row, for example. And then I have this 0 count number, which says, because there's a 0 in the cell if there's no number filled in. So as I go through and fill in numbers in the array, the 0 count eventually gets down to no zeros when the array is filled in. And if it fills in all of the numbers in the array and there's no conflicts, that means that it's found a valid solution and it bails out of the subroutine. If not, it recursively goes back and recurses back through the routine and tries the next number and the next combination, and there so on. So what I've done for this chess routine is I've only restricted it to the numbers 1 through 4, so that it looks at just the chess pieces and I don't worry about all the rest of the pieces. And then as it's going through, again, it looks for these king move conflicts. Let me see here. Yeah, king move conflict, where it looks for neighboring cells that are kings. And then it goes through and looks for the bishop move conflict, where it looks for the bishop along the diagonal unless it hits, again, a knight in between along the diagonal. And then the knight move conflict, where it's looking for every knight move position away. There's 8 different positions based on where the original digit is. But if it's up against a row, an edge, either the top edge, the side edge, whatever, the one that's looking for might be off the grid. So it's got to look for, if you're off the grid situation. So other than that, everything's pretty straightforward. It's very simple. Now, what I've done though is, if I call up that one, this is my modified one with the chess rules. I just put in a couple of digits here. I've got a king here, 3 is a knight here, and another king here. Just to show an example, I go through my brute force routine, and really what I'm doing here is I'm just trying to find a layout of kings, bishops, and knights that obey all the rules, that don't conflict with each other, that aren't overlapping, and basically create a valid layout of the different kings, bishops, and knights. And it actually turns out to be a little bit more of a difficult problem than I thought it would be. And that'll run just for a few minutes here, and then it'll come up and finish. And as I was going through my testing, I actually, let me get this out of the way so I can see that continuing to run. There it goes, just finished. So this just came up with a solution, and again, based on these numbers that I put in, it came up with the first valid solution that it could find, and which is fine, but this does not actually fix all of the problems that I wanted to have in my puzzle to lead the solver down the right solution path to, of how I wanted to create that solution path to go through solving the puzzle. So it actually took me quite a long time. What I was going to show here is I actually went through a whole bunch of different tests looking at different combinations, different layouts, trying to fix things as I go, and it keep trying. It took me quite a while to get to a combination that met all my criteria of what I wanted. So once I found that layout of that criteria, I actually have it here. Okay, so this is the one that I ended up with. So this is the layout that I'm using for my Stalemate puzzle, but this is just the chess pieces. So now I've gone back to my original version of my program, and I had put those in earlier and saved it. So I'm going to restore that back. So I put all of those numbers back into my original program, and now when I go through the brute force routine, it fills in all the rest of the numbers. So all of the 4s, 5s, 6s, 7s, 8s, and 9s, it fills those in to create a valid puzzle. Now, it's not that I don't really care about all of the other numbers, the 4s through the 9s. They're there to make it a fully valid Sudoku puzzle, and that's part of the solution path. But I really wanted to have a puzzle that concentrated, that forced the solver to think about not, the restrictions on the chess pieces as the primary part of it. So this was actually relatively easy. Once I have this layout of the solved puzzle, this is the solution to the puzzle, figuring out what pieces, what numbers to take away for that starting position was actually the more difficult thing. So here's what I came up with. This is what I opened the screen with. This is my starting layout for the puzzle. And as you can see, there's actually very few given digits in the puzzle. And I wanted to make sure that none of the other given digits, the 4s through 9s, would interfere with the path that I wanted the solution to go through to figure out where all the chess pieces are. So there's another tool that I used in this. Well, one is I used just regular old Microsoft Excel, so I created an Excel spreadsheet, and this allowed me to try different numbers, try a 6 there, try a 9 there, different things, and go through and move them around, and try different positions. And so it was kind of an iterative process to find what that layout was. But there's another website that I've used pretty extensively, this Sudoku solver that I found online. Now this might seem a little redundant to my own program that I made, but this is kind of a newer application that has a lot more features than my program did, because mine is pretty bare bones. One of the things that this online website does is it allows to go through and look for all of your standard Sudoku routines that all people use to solve the problem. So hidden singles, naked pairs, hidden pairs, and then there's tougher strategies, X wings and Y wings. But it also has this solution count. Now, the solution count tells you how many valid solutions there are to the puzzle. The only thing is that it does not take into account all of the chess piece rule restrictions. It just looks strictly at the numbers on the board as if it was just a regular Sudoku puzzle. So if I look at my solution count right now, it's going to come up and says, there's more than 500 solutions to this puzzle. That's not true because it's not looking at the chess restrictions. However, I do need to at some point get that down so that there is only one valid solution. Now, the other thing that this website does is it makes it very simple to keep track of what all of the valid numbers are as you go along. So each box here has the numbers 1 through 9, so that you have to eliminate those possibilities as you go through the testing process. So this actually became a very good tool to test my solution. So what I'm going to do is I'm going to go through and look at the solution path and kind of show you what I went through as I was constructing the puzzle. So the first thing that it does when you say take a step is the first thing it does is just eliminates all of the completely non-viable numbers. So since there's a 4 here as one of my givens, this 4 means that there can't be a 4 anywhere in this row, in this column, in this box, etc. So the first thing it does is just takes out all of the completely nonsensical or non-applicable numbers. Now, in my tests that I do, I've got a bunch of these turned off. I've turned off all of the real diabolical strategies and the extreme strategies because I don't even want to be testing for that. I don't want to force the solver, the person solving the puzzle, to use these really, really difficult strategies. I want to make sure that they can concentrate just on the restrictions of the chess pieces, and then just with X-wing and Y-wing, which I actually don't. I did have a version of the puzzle before that did use an X-wing as the solution path, but I ended up not using that. But as I go through and take a step, it goes through and looks for all of the different steps that can do, again, just based on regular Sudoku rules. And pretty quickly it comes up with a stalemate saying, out of known strategies, run out of known strategies. But that's just because it doesn't know about the chess restriction. So now I've got to manually go here to solve this puzzle or to prove that it works. One of the things that I wanted to do right off the bat was have a situation where you can see here where I've got a king and a bishop on a diagonal across from each other. Now, one of the original rules of the puzzle is that the king cannot be on a diagonal with the bishop unless there is a knight in the way. So this actually forces the solver to put a 3 there in the grid just to fix that problem. So it kind of, I tried to make it as obvious and glaring as possible, one, as a first step to get into the puzzle, and 2, to remind the solver of that restriction and remind them that they're gonna have to keep an eye out for that. Now, as I go through again and take a step, I think it finds one more given digit, and I can do this manually, but it would take a long time, and I don't want this to be a really, really long video. I just want to show the steps that I went through when I was creating the puzzle and how I tested it. So I'm going to let the website really do the solution for all of the non-chess pieces, and I'm going to show how you do the solution for the chess pieces. So a couple of things here in particular. So I've got a bishop here. Now this means that this one here can never be a king, because you can never have a king right next to a bishop on a diagonal because there's no place to put a knight in between. So this one, I had to remove that one there as a possibility. This knight here that we've put in means that this one can't be a king. Again, you can't have a king and knights move away from the knight. So as you go through, and I take out a couple of these, I've got a bishop there, I've got a bishop there. There's a whole bunch of them, but as I go along, if I take a step, it's all of a sudden going to find, let me see, there's no bishop here. Okay, and that's the last bishop along this row except for this one. So now when I take a step, it's going to find that as a single and fill in that. And then it's going to find that because of that, I've had to eliminate all the other ones, and it finds this other bishop over here as a single. And then that allows it to fill in a couple of other numbers. That's fine. Okay, it comes to another standstill again. Now, I'm going to go ahead and remove again some of the possibilities. This king here means that this one down here can't be a knight. And this one here cannot be a king because you can't have two kings next to each other. This king here, you can't have a king next to it. So I'm going to eliminate that possibility. And then I'm actually trying to get to a certain, I'm not actually doing all of them because I want to get to a certain point. What am I looking for? Okay, this knight here means that this one can't be a king. Okay, I think this one does it. So once I've eliminated that possibility of a king, the only king that's positioned left in this whole box that can be a king is just this one up here. Now, once I do that, this again puts me in the exact same position that I was in this first box where I have a bishop and a king diagonal from each other, meaning that I have to have a knight in between. So that kind of forces me to place a knight there in that position in between the bishop and the king. And now with that knight there, it means that this one up here cannot be a king. And again, now I've got, and it means that this one can't be a king either. So now I've only got one more position in the box where a king can be. So it's going to go ahead and find that, fill in that one. It's going to go through and find a couple of other numbers here. Again, I'm not going to worry about those. Okay, so now I come to another standstill. So I'm going to keep going. So I filled in this one. I've got some additional, let me see here. There. Okay, here we go. So this king here means that this one cannot be a knight. Once I do that, there's only one knight left there in this box, so it's filled that in. It fills in a couple of others. It keeps going. And, again, filling in some of the other numbers. Now, it starts to get a little bit tricky. You'd think that as you go along that the solution would get simpler, but it actually gets a little bit more difficult. I come to a point here where I've actually got to remember, because I've been stepped through this so many times, but the steps get so complicated that I forget a lot of them. So this one here can't be a knight. And then bishop here. There's another one that's actually pretty critical for taking that next step. And yeah, here we go. So here we have another situation where I've got a king in this cell here, looking up here, and this one can't be a bishop because this bishop would put the king in check. So I can take that one away as a bishop. That fills in that next bishop next to it. Now I get to the point here where I've got two kings down here at the bottom. But one of them actually is looking up here at this bishop up at a diagonal. Now, the rule is that, there could be a knight in between, but the only open position here is this one. And there's already a knight in that column. So I cannot put a knight here, which means that along this diagonal, then this one cannot be a king. So that eliminates that possibility as being a king. As I go through, there's another critical step that I need to take, and I'm not seeing it at the moment. Give me a quick second here. 3, 1, 3. And let's see, oh yeah, right here, this bishop is looking at this king here, and then that leaves the only lone king in the box at that point. So if I take a step there, that's going to fill in that king, and that also fills in this king down here. Now, once I have this king down here, I believe that leaves the only bishop left there in that cell, and that finds a bunch of other numbers. And I think the rest of the puzzle kind of solves pretty quickly. I actually, this one along the diagonal, I went ahead, since I know about it, I went ahead and filled that in early on. If you don't fill that in, you kind of get to a point here where it gets stuck again, and that's kind of the key to going through to the final solution. But all the rest of these numbers now solved. So that's the final solution that you get to. Now, the problem that I kept having as I was going through this process of creating the solution is I never really I wanted to guarantee that I had a unique solution. That's one of the primary rules of any Sudoku puzzle, is that it must have a unique solution. So finally, what I ended up realizing, I'm going to recall my initial setup because I'd saved that on the board. Finally, I realized that if I know that all of my chess pieces, my kings, knights, and rooks, are in a unique position and absolutely are solvable just on their own as being a unique layout. I realized that if I took my starting position of the board, including all my given digits, my 4s, 5s, 6s, 7s, 8s, and I put the rest of the given chess pieces in the board, then that should be able to prove that I've got a unique solution. So if I go through here and fill in one, oh, that's my wrong, sorry, my wrong image here. Here it is. This is the one I'm looking for. Got a 1, 2, I've got a knight there, knight, or bishop, knight, king, king, bishop, knight, bishop, or knight, king, bishop, 3, 2, 1, 1, 3, 2, 2, 3, 1, 1, 2, 3, 3, 2, and a 1. Now, so this is basically all of my given digits plus all of the chess pieces. Now, when I do my solution count, it goes through and says that I've got a valid puzzle. Now, if I want to remove any one of those digits, say I remove that 8 there as a possibility and do a solution count. Whoop, that one didn't seem to make much of a change. Let me remove that 8 as well. Okay, so when I remove that 8, that says that I've got three valid solutions. So that 8 that I had in the board is critical to hone that down to make sure that I've got one valid solution to the puzzle. Now the trick that I went through, again, since this took many hours and trying different combinations, it was very much a manual process. I wanted to make sure that the given digits that I put on the boards, all of the 4s through 9s, did not interfere with that solution path that I wanted to take for the chess pieces. They're there, they're great, but I didn't want to have that box in and make it so that it was too easy to find the chess pieces just through normal Sudoku moves. I wanted to be able to find the chess pieces through these restrictions of not, of how the chess pieces interact with each other as the actual solution. So that's really was the main driving force behind, getting this layout of this initial puzzle layout that I started out with. So now let's look at the second puzzle, the Checkmate puzzle. And like I said before, this one is a little bit more difficult, both in its solution and its, constructing the puzzle. And it also has fewer given digits to start with. So I'm just going to start from scratch here and just fill all these in. I've got a king, a 6, a bishop, a 7, a 5, a knight, a 7, 6, a knight, down here is a 4, over here we have a 8, 6, 5, a king in the corner, an 8, a 9, a king here, a bishop, and a 5 there. Let me see here. 1, 6, 2, 2, 7, 5, 3, 7, 6, 3, 4, 8, 6, 5, 1, 8, 9, 1. Oop, that's a bishop, not a knight. So that's a 2. 1, 2, 5. All right, I think I got that right. All right, so now again, I've got all the the digits given. So this is the initial starting point for starting this puzzle. So again, we kind of go through the exact same process that we did on the first puzzle. We go through, take some steps, and it's going to go through, and pretty quickly it's going to get to a point where it's just going to say there's no next steps. It can't find any places to put any pieces based on normal Sudoku rules. Now, as I said before, the center box, since the rule of this game is that wherever the king is in the center box, it's in check by one and only one piece, which means that right now I've got, let me see here, this 2 is looking at this king here, but I can't eliminate that king because I don't know if that's the king, that's in check or not. So I can't take that one away right now. So kind of the first solution path that I'm hoping that the person goes through to solve this problem is over here on the right hand side. I've got this knight here. This knight will eliminate these 2 kings as possibilities, and then this bishop will eliminate these 2 kings as possibilities. And that when you do that, that leaves only 1 king left in this box. And now when I take a step, it's going to find that as a naked single or as a hidden single, and actually it finds 2 of them. But once it puts that king in there, down here along the side, it's going to find this next king down here and fill that in. So that kind of gives me a kickoff point to the whole puzzle. Now I can kind of go through, and so here's kind of a trick here. So this knight here, even though it's inside the middle box, it's putting this king in check, but the king that is putting in check is outside the middle box. So we know that this can't be a knight. So that can't be a 3 because it's putting a king outside the box in check. So, I put in a couple of things like that, again, to kind of hopefully steer the solver along the path of, to the solution. And again, the same thing with this bishop here. So even though this bishop has this king in check, we don't know if that's the king that's in check. It also has this king outside the box in check, which means that that cannot be a bishop. Again, going down that path of eliminating the possibilities. So you kind of like a funnel. As you go down the funnel, you're narrowing in on the one true solution. Now, once you get to that point, it actually does solve for the king. I tried to make it so that the king appeared a little bit further down the solution path, and I had a couple of earlier iterations of the puzzle that did, but other parts of the puzzle got a little bit too complicated. However, it turns out that it's actually still fine. So even though you do find the king in the center box relatively quickly, now I'm going to go ahead and take a step and get it to the next, wherever it can't find any more pieces just on its own. Okay, there we go. So now you know that this is the king, but it's in check here by this bishop, potentially by this knight, So you don't know which of those pieces is the one piece that gets that king in check. So we're going to go through and just continue along the path. So here I've got a knight over here. That eliminates that king as a possibility, which leaves only one king here. And I think once you do that, it kind of fills in all of the kings in the puzzle. 1 1 1 1 1 1 1 1 1. Yeah, so I've got all of the kings placed now. All right, so this king here eliminates these two knights as possibility. Now, again, this is kind of interesting. Oh, that one doesn't actually see the one in the center, so that's fine. I'm not worried about that. And then this bishop here cannot be a bishop because the king would be in check. So I think that leaves a lone bishop, but there's still two knight possibilities. So I've got that bishop there. Now, an interesting thing is that bishop actually puts another piece that's a possible contender, putting the center king in check. So it's kind of a, adds another wrinkle to the variable. Now, here's where it gets a little bit tough. And again, even myself, as I've gone through this so many times, I get confused a lot because the logic is a little bit complicated here. So as I go through, this knight, this box cannot be a knight either for either one of these kings. Now we have a row of 3 knights here and a row of 3 knights here. Now it turns out that this king sees that knight, this king sees that knight and that knight. And once you have all of those, now that just leaves these 3 kings down here. Now again, there's a bishop here that's got this king in check. And this king sees this knight. So that one can't be a knight. And I've got to, again, remember my logic for the next piece. And as I look through here, okay, so there's another, here we go. So this king here means that this one can't be a knight. And as I take a step there, now that means that this one is a knight. And then that leaves, by regular Sudoku rules, the only knight that's available in this row is this one right here. So that actually is what whittles it down to being the knight. And this is then the one knight that puts the king in check. So again, it's kind of a convoluted way to get there, but it is an absolute, no questions, that is now the one piece that puts the king in check so that it's in checkmate. Now, once I have that, again, the rule is that the king is in check by one and only one piece. So now that I know that this is that piece, I know that that can't be a bishop, that can't be a bishop. And actually, because now, let me go ahead and take a step here. It's going to keep going, fill in the rest. I come to another stopping point here where it can't take any more steps. Again, it turns out that I've got another bishop along this diagonal up here, which forces me to put a knight in that position there. And I believe that that's the last one that really makes a big difference. And the rest of the puzzle should solve from there. There we go, and that's the solution. So again, let's go back through the what we did with the first game. I'm going to reload that game that I saved. Oh shoot, I didn't save it. God darn it! So this is the original puzzle. I didn't save my second one. So let me clear this. Hold on a second. Sorry about that. 1, 6. Bishop is a 2. Got a 7 there. A bishop there. 5. A knight. 7. A 6. A knight there. 4 there. Kind of off the side there. 8 down in the corner, 6, 5, king there, 8 there, 9 there, king over here, bishop, and a 5. So again, this is my starting position of the puzzle with all my givens. Let me just check that. 2, 7, 5, 7, 6, 3, 4, 5, 1, 9, king 8. All right, now I'm going to save that just to make sure it's saved. And now I'm going to go back through and fill in all of the checkmate chess pieces only. I'm going to add all of the rest of the chess pieces to the puzzle. 3, 1, 2, 1, 2, 3, 3, 1, 2, 1, 3, 2, 3, 2, 1, 1, 3, 2, 2, 1, 3, 3, 1, 2, whoops, 2, and then 2, 3, 1. So again, this is all my starting digits to the initial layout of the puzzle, plus the chess pieces, which I know for sure are a unique solution. And now when I say solution count, it comes back and says, you know, there's one solution to the puzzle. So that was kind of how I went through and verified that, you know, once I did have this layout that I wanted to have as my puzzle, I verified that I did have a unique solution and a valid puzzle. Now, again, this is my very first time ever creating a Sudoku puzzle, so I'm sure there's a lot of things that I could have done to make the process more efficient and a little bit cleaner. But actually, I'm pretty happy with it. It's a difficult puzzle. It's not an easy puzzle, but it's not killer. You don't need to use any of these diabolical strategies, you know, jellyfishes or unique rectangles, which as I watch the channel Cracking the Cryptic, a lot of times Simon and Anthony will get to those positions and they need to use these advanced strategies, and it always boggles my mind. One, I can kind of follow the logic for how to solve it, but I can never recognize them when you actually have that situation in the puzzle. So I wanted to you know, stay away from those. Anyway, that's my video. I hope you enjoyed it, and have a great day. Thank you.